This video is looking at algebra, dealing with indices. So that's when you have terms that are raised to the power of something. We already know that if you had something like 3 squared, that's 3 raised to the power 2. We know that that is the same as 3 times 3, which becomes 9. If it was algebra and we had letters in place, we would see things like a squared, and that would simply be the same as a multiplied by a. Of course, we don't use the multiply sign when we've got algebra. We would use the a squared, so we would see that written as a squared. And if you had an algebraic expression that said something like a squared plus a plus 2a plus 2, and you were trying to simplify this, you wanted to collect like terms, it's really important to realise that a squared is not like an a. A squared means a multiplied by a. You can't add those two terms together. If you were trying to simplify this expression, the a squared would stay on its own. We would be able to collect the plus a and the plus 2a. Combining a and 2a would give you 3a, but you would keep the a squared as it is and would keep that plus 2 as it is. So if you're trying to simplify algebraic expressions when you've got some terms that are raised to powers, you can't combine them with terms that are raised to a different power. If you had an expression that was 2b squared plus b squared plus b, then you would be able to collect these b squareds with this b squared. So 2b squared add on another b squared would become 3b squared, and then you would have this last b to add on, so that would become 3b squared plus b. If we had an expression where we had to multiply two terms together where the terms were raised to different powers, if we had a squared and that had to be multiplied by a cubed, that would in fact be, well, the a squared part is the same as a multiplied by a, and the a cubed part is actually a multiplied by a multiplied by a. So if we're trying to multiply that, which is the same as that, by that, which is the same as that, our expression, if it was written out in full, would look like this. We've got a times by a times a times a, which in fact becomes a all raised to the power of 5, because we've multiplied a by itself a total of 5 times. And you'll notice here we had a 2 and here we had a 3. When you're multiplying in algebra with the indices, the indices that you're multiplying against, you're actually going to add those up. So a squared multiplied by a cubed, you add the 2 and the 3, that gives you a to the power 5. If you've got a situation where you're dividing with the indices, let's use the example a to the power 4 divided by a cubed. So what is that equal to? Well, a to the power 4 simply is a multiplied by a multiplied by a multiplied by a, and that's all divided by a cubed, which is a multiplied by a multiplied by a. Now, of course, when it's written as a fraction, we can see that we can divide, as long as we divide the top and the bottom by the same thing, then our fraction still works. So I've got a times by a and a times by here, a, which I can cancel, and I've got another times by a here and another times by a here. And then if I divide by another a and another a, that leaves me just with, I would just have 1 as my denominator, and that leaves my top line just as an a. So I've got just the value here would become, that's all equal to a. Now, if you notice, I've got a raised to the power 4 divided by a raised to the power 3. 4 subtract 3 does give me 1. So a on its own is the same as a to the power 1. We wouldn't normally write that 1 because it just means it's just a on its own, so it is just a like that. So you can subtract the indices when you're dividing like that. And finally, we'll look at the situation when you've got indices that are sort of outside brackets. So if you had something like this, 4a cubed, and then you've got that in brackets, and then that's all raised to the power 2, that's all squared. That would mean, well, inside the bracket it's 4 multiplied by a, multiplied by a, multiplied by a. That's all that 4a cubed, I've just written that out in full here. But because all of that bracket is squared, it means that I've got to multiply that by itself. So I've got another 4 times a times a times a. So now, when I multiply everything out, you can see, well, the numerical part, the 4 times by the 4 becomes 16. And then I look at how many a's I've got. I've got a multiplied by another a, multiplied by another a, multiplied by another a, multiplied by another a, multiplied by another a. So that means that that's a to the power of 6. So this becomes 16 a to the power 6, 16 times by a to the power 6. So if we have got this situation where we've got indices outside of brackets, that means that's got to be this has got to be applied to everything inside the bracket, because of course we have to follow the rules of BIDMAS, so we have to apply that to everything. That obviously we need to apply that power to the numerical part, so the 4 became squared, which gave us the 16. The a cubed, that 3 got multiplied by that 2. So that 3 times 2 gave us that 6. So when you've got indices outside of brackets, that's when you would actually multiply them to get you the final power that you need. So the golden rules that we need to remember whenever we've got indices within our algebra. So if you've got terms that are raised to different powers, you can't collect them together as like terms. So if you've got x squared plus x, that would stay as x squared plus x. You wouldn't be able to combine those in any way. When you're multiplying, you add the indices. So a squared multiplied by a cubed becomes a to the power 5. When you're dividing, you subtract the indices. So a to the power 5 divided by a to the power 3 is a squared. If there are indices outside the brackets, then you multiply the brackets. So a cubed, if all of that is then squared, that becomes a to the 6. And finally, just by convention, in the same way that if in anything with algebra, if you had 1a, you would actually just write that as a. It's exactly the same if you had indices. If you had a just raised to the power 1, again, you would just write that as a.